Today, first off, we are having class on Friday. I am not going to be here with you. I have to attend a university function in the Vista room for that event. So what we're going to be doing, Ms. Dunlap's going to actually be coming in. There'll be a sign-in sheet for you guys to check in. We're going to be watching a video. I'm trying to decide if it's going to be one on Amazon or possibly about the history of YouTube yet. I'll make that decision. She'll be starting the video for you guys. Please show up, guys. It's one of these things. She will be taking attendance. I will be noting it. And it's going to be an easy class where you're going to have some opportunity to really learn something as well. So, guys, we're going to be starting off today. I'm going to be reviewing Chapter 2 with you. And again, the kind of questions you see here, for those of you who've had me for class before, should seem pretty familiar. You get an idea about what we're talking about. We're also going to be starting Chapter 3 today. And we're going to be starting off because we're just getting done with our business model side of things. We're going to be talking about YouTube and their recently released statement of earnings. Before we get in, guys, just a reminder that this Friday you have the business model part of things is due for your idea. Are there questions in terms of what I'm asking for? I put the template up there so you have a visual on this. Bullet points are absolutely okay. Don't worry about writing full paragraphs. Answer each of these questions in bullets, and we're in good shape. Are there any questions? You guys feeling good? All right, let's jump in to a little bit of current events before we do our review. And the current events are our good friends at YouTube. Eyes up front, please, guys. Our good friends at YouTube actually just revealed their revenue. This is the first time YouTube has ever revealed its actual revenue. For 2019, that should say ad revenue in 2019, not 2020, $15 billion. That sounds like a lot of money, and it is. It's actually a faster growth rate in terms of percentages than Google, its parent company, Alphabet, is seeing itself. That being said, their room for growth is definitely there. Just to give you some perspective on this, if you took every Facebook user who is using Facebook in the last quarter of 2019, for every user, based on ad revenue and the money that people paid to reach those users, every user on Facebook generated about $7.26 of revenue for Facebook. If you want to know how powerful that is, do the math on it. How many global users does Facebook have? Any ideas? Take a guess. How many do you think? You have 2 billion, you said? It's actually over 3 billion. So those are U.S. numbers in terms of the revenue they're making. YouTube, for the entire year in the United States, made between $7 and $8 per user. So there's a lot of room for growth there. We're going to start off today with a very brief video kind of detailing financially what's going on with YouTube. Google is going to close anytime soon, but we're talking about YouTube that is growing at a faster rate in terms of ad revenue than Google per se is. Guys, any reactions to this before I ask you some questions? Yes, sir.
To me, it's surprising that YouTube is still growing that fast because I've been using it since it first came out, and it from 2008 to 2012, it got a lot better. And then you can pretty much upload any content, you don't get demonetized and all that stuff. But then literally the last probably 3 years, you just say a curse word or anything, you just do anything slight, and you get demonetized. So I'm surprised that people are still growing that fast.
So the growth rate is surprising. What do you think is driving the growth rate, guys? Because that's true. They're making it harder for content providers to make money. They're making it more difficult to post some kinds of content. What's driving the growth? Your thoughts? I have some ideas, but what do you guys think? It sure is. And what's changed in the last 5 years in the way we consume YouTube? Mobile for sure. And is there another one? You got it, smart TVs. So all of a sudden, we're talking about HD content. In the old days being 5 years ago, you might be watching it on your small screen laptop. Now you can watch it in full HD in the comfort of your living room. And advertisers are noticing this stuff too. In the original days of YouTube, when we started first getting ads, they tended to be national. How many of you have seen on your home televisions a regional commercial come up on YouTube? Yeah, we're talking about geolocation now. They're really acting more like a regional broadcast network at times than they're operating like a typical streaming service. Well, here's my other questions, guys. Are there other things that are drawing us to YouTube as opposed to other ways we can entertain ourselves? What's drawing us there? Yes? For sure. And I would argue, I would like, actually, I'd like to get your opinion on this as well. I think in some ways that YouTube has actually lowered the bar in terms of what we expect from quality of content. For example, if we look at very sleekly produced promotional materials from a company saying we want to market our car or our laptop or our sneakers versus somebody who's making a video themselves and talking about the product, which one do you take more seriously now in terms of somebody telling you the truth?
Somebody reviewing because they'll just give you straight up answer instead of giving you some BS or something.
Exactly right. If you're somebody who's into shoes or if you're into phones or whatever, some guy sitting in their bedroom or girl sitting in their bedroom who's actually unboxing this thing and using it is giving you more of the straight story than somebody who's being paid to give you that information. In some ways, it's actually lowered the bar. And the funny thing is that the people who've become good at it now are raising their own production standards back to be broadcast level. Here would be my question, my final question for you before I open it up. In terms of where we're at here, you can see obviously Facebook is making a lot more money than YouTube is at this point. What would you tell YouTube their next move should be? In terms of further monetization, in terms of making more money, in terms of continuing their growth, what recommendations would you make? Yes?
You don't want to happen, but show ads more often.
More ads?
Like I've been using YouTube on Xbox since 8th grade, and I used to get ads all the time. In the last 2 years, I barely get any ads anymore. It's just weird because I'll use YouTube on my laptop, on the TV, and I get ads more often than there compared to my Xbox. I don't know why.
That's interesting. I wonder if your Xbox is unintentionally getting around.
I used to get like 5-second, 15-second ads all the time, and I just barely get. I'm not complaining.
Yeah, I mean that's pretty cool. I hate the ads that come in the middle of a long video with no apparent draw in. What else would you guys be telling YouTube?
Go ahead. Making more of a way of making utilizing their popular creators, because I think for our generation and especially the younger generation, celebrities don't mean as much as they did to generations above us.
Right.
And I think a big thing is they're more relatable. A lot of them came from similar backgrounds, or they weren't anything crazy. So it was cool to see their progression. So I think finding a way to take these now internet celebrities and build their internet celebrity fandom rather than making them television celebrities. Because I know YouTube, they already tried, and I don't think it worked. With YouTube Red, certain popular YouTubers can make a YouTube series, and you have to pay that YouTube Red subscription in order to be able to watch it. But are you if you're used to watching someone for free, is it worth you to pay $10 a month to be able to watch their premium content?
It really never caught on, did it?
I don't think it did.
And by the way, this $15 billion does not count any subscription revenues that they're getting from YouTube Red or other providers. Yes.
Isn't it if a video gets demonetized, there's no ads in that video? Is that the case?
Yeah, that's the case.
So I think they should, just go back out a couple years ago and just stop demonetizing so many people. Because if you go to the training page now, it's just a bunch of junk. Compared to what it used to be, it's a bunch of junk.
They're definitely not giving people a lot of incentive to create content in that way.
This is a little off topic, but I was in my house, we were just listening to music on the TV with YouTube, and we didn't change the song while we were just letting it play, and we noticed it wasn't playing music for a while, and there was a 45-minute advertisement.
Wow.
It was like a full movie, pretty much. It was like an ad. We were obviously going to skip this, but why was there an ad that long?
What was it for?
There was like a celebrity, there was Emma Stone was in it. She was advertising something. I didn't stick around to watch it, but it was so long.
Wow, that's crazy. Wow. Go ahead, Aaron.
I would say with the demonetization, I definitely agree that it's getting to a point where it's kind of excessive. If you do anything, then you get demonetized. But I think that actually might, if they went back to how they were, I feel like they might actually lose some of the companies, that are putting ads in the videos. Because I know some companies were upset with their ads being on certain content. So if that company doesn't want the image of whatever's in that video content, then I think that it is also keeping some companies with YouTube
Well, I got to tell you too how good Google's algorithm is. Years ago, and I apologize, I've told you this story before, but it just impresses me how good their analytics are. Google, we used them for streaming. Actually, in the early days, we used YouTube. I'm not sure if the university still does or not, when they streamed graduation. And what happened was the very first year we were streaming graduation using the live YouTube. Keep in mind, YouTube wasn't always available to do live stream. The first year it was, we put it up. Here's what happened. Now, before the graduation ceremony starts, people are mulling around. There's background music. It got tagged as copyright, or potential copyright infringement, and it killed the stream immediately. It took it about 5 minutes to knock the stream down. So people were scrambling to get the account unlocked. 5 minutes before noon when the ceremony is supposed to start for all these people who want to watch their kids graduate. That's how good Google's algorithms are. So it is a big deal. Last question I have before we leave this. I'm sorry for spending so much time on this. Does that figure surprise anyone? 15 billion. Anybody thought it would be higher? Or is that about right? What are your thoughts? Yes.
I thought it would be lower because I noticed that a lot of companies that want to advertise their product are like reaching out to like the people who make the video directly. So instead of having like an ad from YouTube, it's like the content creators actually saying like, hey, this is
Within the content.
Yeah, within the sharing video.
Yeah. I have to admit, I guess I didn't have context because this is the first time YouTube themselves have ever spoke about their revenue. I guess I expected it maybe to be a little higher, but that's still nothing to sneeze at. But if you're Google, for example, if you're a $1 trillion company, that's still a sizable contribution considering how little of a part of the company it still is. Any other comments before we start with our Chapter 2 review? Guys, keep your eye on this. I think it's pretty interesting how this stuff is shaping out. Whenever we do this stuff today, guys, just feel free to shout out the answer. And these are pretty typical of the questions you'll see in one of the exams in this class. True or false? E-commerce has largely destroyed price dispersion. Is that true or false? But price dispersion, does it mean everybody's paying the same price no matter where you go? It is false. There's still a lot of price dispersion out there. A set of planned activities designed to result in a profit from the marketplace. Is that your business model, your business plan, your e-commerce business model, or your e-business model? Feel free to use your notes. No electric shocks will be delivered for wrong answers. Guess is for B, and it's actually A, business model. Business plan is a derivative of that. Which of the following is not one of the key elements of a business model? Is it value proposition, revenue model, advertising strategy, or organizational strategy? C is correct. It's actually a marketing strategy. It's a semantic term, but that's what we're learning in here. True or false? Your competitive environment is why the customer should buy from you and not someone else. That is false. What is it? It's your value proposition. That's the term. All right. eBay, I'm sorry for the font on this one. What is eBay's primary revenue model? Is it advertising, subscription, affiliate, or transaction fee? It is D. They absolutely have a transaction fee. True or false? Amazon Prime Instant Video is an indirect competitor to Netflix. Careful with this one. Why is it false? It's a direct competitor. Absolutely correct. True or false? The first company in a new market space almost always dominates. That is false. Can somebody tell me a first mover who was a failure? Pets.com. Good one. How about one more? I'm sorry? BlackBerry. And surprisingly, because they had market dominance for a long time. One more. What's one we talk about in social media? The first major social media. MySpace, which is nothing now. Which legislation affects crowdfunding? Is it Sarbanes-Oxley, Patriot Act, Jobs Act, or Digital Millennium Copyright Act? It is definitely the Jobs Act. Which of the following is an example of a community provider business model? Is it eBay, Amazon, Target, or Facebook? It is Facebook. Facebook is our community. Which of the following is an online version of a traditional retailer, such as JCPenney.com, for however long JCPenney.com is around? Is that a content provider, a portal, an e-tailer, or a market creator? C is correct. It's just a traditional retailer that goes online. Which of the following is a content provider? East Bay, Netflix, Nike, or Ford? B is correct. Although the lines get fuzzy these days with some other companies producing content. Which of the following uses a transaction broker business to consumer models? Ameritrade, Amazon, Walmart, or Sears? I'm sorry? It's not B. Think about where you would pay a fee. Although Amazon technically does with some of the third-party sellers, I could buy that. A would be the best answer because you
Yeah, I don't know what it's A or B.
Ameritrade is an online stock purchasing program. So you guys are managing your portfolios during class time. That's okay. And Sears, it surprises me they're still around. An online version of a business-to-business retail and wholesale store. Is that an e-tailer, an e-distributor, e-procurement, or e-value chain? We're selling supplies. B is correct. True or false? Business-to-business exchanges have reduced the number due to drastic price competition. Is that true or false? That is absolutely true. Remember, we were talking about the idea that it was cutting down on profit models so much for some of these providers that it was no longer profitable to be part of them. Large groups such as Walmart manage their commerce using what? Is it industry consortia, exchanges, private industrial networks, or vertical exchanges? How do they manage their enterprise? How do they connect? I'm giving you a hint. It is C. So, private industrial network. If you're networking with other people, it's a private industrial network. A set of activities performed by suppliers, manufacturers, transporters, distributors, and retailers that transform raw inputs into final products and services. Is that B2B e-commerce? Is that an industry value chain, a private industrial network, or an industry value web? It's actually B. It's okay, guys. That's why we review. The two parts of the traditional industry and value chain that e-commerce cuts off is the distributors and retailers, distributors and customers, suppliers and customers, or suppliers and manufacturers. Who's it cut out of the chain? It is A. Because we're selling. Let's talk about this for a second, guys. If you're cutting out distributors and retailers, we have people, for example, we're making a product. So we're company X. We'll put a little smokestack here. And we're making a product that typically, through some sort of distribution method, whether it's trucking, train, whatever, that goes out to a distributor, which goes to a retailer, which ultimately goes to a customer. Each one of these pieces adds cost to the customer. If we're able to go directly to the customer, we are essentially cutting out distributors and retailers. That's why e-commerce is so powerful, because we're cutting those people out. All right, a service that has a free and a for-cost option. Is that streaming business model, freemium, value-added, or service? It's freemium. It's not premium, it's freemium. Can somebody give me an example of a freemium product? Yes. Anybody have this one? I bet you some of you have it on your phones. YouTube would be an excellent model because you could get YouTube Red if you wanted to. Is there another one that you have? Spotify. Well, I don't mean 4 is in the letter 4, but for cost. Like, no worries. That's why we're covering this, guys. But yeah, YouTube would be a great example. So would Spotify. And that's chapter 2, guys. Before we jump in, we're going to be jumping into chapter 3 today, and we're going to be giving you a basic explanation for the technology underpinnings of the internet. Now, all of this in here, I know we've got a couple computer science folks. This will be easy for computer science folks who've already studied networking. It's still going to be a nice history lesson. For those of you who are not computer experts, we're going to be breaking this down into common terms. It's important to know this stuff so you can understand what actually makes the internet tick, and that's what this chapter is all about. Before we get in, though, because we've been going pretty good and fast here so far, I'd like to get a question or comment from somewhere in the room. Question or something you'd like to say? Well, take a sip of my delicious beverage. It can even be off topic. You have my permission. Anything you guys would like to talk about? Keep in mind, I'm following the TED Talks model. The TED Talks model. How many of you are TED Talks fans? Well, yeah, nobody watches TED Talks. They're awesome. TED Talks, one of the best things I ever saw said that the average human being, how long can a person realistically pay attention? It is 17 minutes. So if you go longer than 17 minutes, you're essentially setting people up not to retain anything, which is why I take breaks right around 17 minutes. So somebody asked me a question about something, so we can, or make a statement. My favorite Marvel movie? Oh boy, that's a good question. Are we counting the Fox Marvels too?
Like, X-Men and all that?
Yeah, does that count?
Yeah.
So it all counts?
Oh, yeah, I didn't say MCU.
Okay. Logan. Logan might be one of the best movies ever made. Like seriously, even if you don't like the X-Men, if you can go see that movie and not feel something at the end, you're a harder person than I am. Like that last scene. How many of you have seen that movie? It's really graphic. Yeah, the end scene. Well, can I give a spoiler? Is that okay? You guys, the rest of you plan on seeing it? When what's Logan's biggest superpower? He heals from everything. And the last scene when he's dying and he looks up and says, "So this is what it feels like." It's like, oh my God, just amazing, amazing. But Hunter, you had your hand up too.
I saw this. I was like on Facebook, but like they have like pizza delivery robots, or like just like delivery robots in general that like drive up and like deliver things. I'm like, do you think that's like a good idea? Not like a good idea, but like efficient.
Mm-hmm. They're testing them in Georgetown actually, and here's the challenges they're having in areas like ours that even though it's February this year and there's no snow, usually get bad weather. The question is, how will they do in those kinds of conditions? And there's also a few YouTube videos floating around of people who've tried to steal from those. Because have you seen the ones I'm talking about, the rolling coolers? Yeah. And if you guys have never seen these things, it would be conceivable that somebody could steal them. There's cameras on them; you'll get caught. But I think it's a pretty neat idea. I mean, I think it's no crazier than Uber Eats on a local level. I don't think. Would you order food from an automated delivery service?
Yeah. It's not necessarily that, it's just like technology is great when it works.
Yeah.
But, like if there's an issue and like your food doesn't show up, I'm sure there could be like just I mean it happens in regular delivery too.
I want to make a comment to that, and we'll jump into our discussion of the internet today. I think that sometimes technology for the sake of technology is a mistake. And here's my best example. A few years ago, Sheetz decided to completely change the way they were doing sugar and coffee at the restaurants. So if you wanted to get sugar and cream for your coffee, instead of using a manual process where you use a dispenser or whatever, they put these push-button systems in. They weren't difficult. Anybody and their brother could go up and figure one out. But the very fact that because so much of the population who goes to Sheetz couldn't figure it out, they actually had to hire people to stand at coffee stations that day to show people how to put cream in their coffee. If it's that complicated, you've got to actually pay people to show people how to put cream in their coffee. And, by the way, it takes longer to do it that way, even if you know what you're doing. You've inserted technology where there wasn't a problem. And I think sometimes we have the tendency of doing that with technology, too. If it creates more time, if it takes more time than it did manually, then technology is probably not helping us. That's my opinion. So, all right, guys, we're going to jump in to a little bit of a history lesson, but a little bit of a technology lesson, too. We're going to be talking about what the web is all about, how the internet came to be, how it came to be in our lives today, and why it surrounds us so much. You guys remember I used the term for the internet saying what kind of network it was. Do you remember what I called it? It has to do it sounds a little like Wolverine. It's a self-healing network. And so that's one of the wonders of the internet is you're going to see when we go to original packet switch networks, packet switch versus circuit networks, why this was such a revolution, why it's changed the way we've done things. These kinds of technologies are why we have e-commerce as we know it today. I have no doubt that if the internet had not come into existence the way we know it now, and if we did not have access to the web, large companies would still be doing business in some sort of online data interchange. You and I, however, would probably not use technology the same way. And we're going to talk about the impact of mobile as well. So a good description for the internet is basically a wide-ranging self-healing network. It connects us. It's like, for any of you Star Wars fans, it's like the Force. It's all around us and binds us all together. It's sort of like the Force, except not as many special effects. The World Wide Web, write this down, is not the same thing as the Internet. The World Wide Web is a service on the Internet. It's one of the most popular services on the Internet, and it's how most of us use it, but it is not the only thing on the Internet, and it is not the Internet. Before we had World Wide Web service, for example, has anybody ever done FTP downloads, for example? You know, you've done things that didn't require you using a web browser at all. When we first got into using the web, for example, we didn't even have domain names. We used manual IP addresses. We entered in numbers to get to pages on the Internet, to get to pages on the World Wide Web. So the World Wide Web is a service that provides on the Internet. Now, we start talking about, well, where did this stuff come from? The building blocks for the Internet came into existence before the Beatles made it big on Ed Sullivan. So we've had actually the underpinnings of the Internet longer in the United States than we've had the Beatles. That's how far back this stuff goes. The innovation phase, 61 to 74, the Internet and the things that have made it possible from a technology standpoint were being developed by the United States military, they were being developed by academics, they were being developed by scientists, and there was not an immediate commercial application. What was the Internet's original purpose? Remember, we talked about this last chapter. What was its original intent? Yes?
Military communication, because it was self-healing. If modes of communication went down, then they could still have other ways to communicate.
Exactamundo. It's a self-healing network. So the idea being, God forbid, if we had a massive attack on the east coast of the United States and those network nodes got knocked out, the rest of the network would reassemble and we'd still be able to communicate. So that was the first phase, 61 to 74. Well, we started getting into 75 to about 1995, and universities and academics really started getting involved with this, saying, wow, this is something we can use for research. This is something we can use for supercomputing. Let me give you an example. You guys are carrying around massively powerful computers compared to where we have come from. If somebody wanted to have the computational capacity to carry around on your laptops, we used to have to use a mainframe. And the mainframe is located in a central location, usually around a big university like Carnegie Mellon. And occasionally, if you were lucky, you could use a network to actually log in and use computation cycles at that central location to do your complex calculations. In fact, guys, anybody here have any idea where our actual internet connection comes from at St. Francis? Where are we ultimately going to? Yes?
Is there a server room over in the library?
All the server rooms actually, there's servers in SCOTUS and in the library. But when we leave St. Francis, how are we getting to the big bad internet? So I'll give you a hint. It's another university. It's a good guess. We're going that direction.
In Pennsylvania?
It is.
Harrisburg?
It's actually Carnegie Mellon in Pittsburgh. The Supercomputing Center at Carnegie Mellon is a major gigapot for the internet in this part of Pennsylvania. They do so much with the internet that they are one of the places where you can, essentially, for lack of a better term, where you can hook onto a main line. And that's why we go back to them. So early adopters like Carnegie Mellon were involved in this stuff. And finally, we get into 95. So we go from government and academia to mainly academia and experimentation to commercialization in 1995. And the world changed because all of a sudden we can do this at our homes. I don't have to go to work anymore to use the internet. So this internet that came about happened for a few reasons. Number one, IP addressing was a revolution. The idea that we could have unique internet protocol addresses that would allow us to go anywhere on this massive network. And this supports something called Transmit Control Protocol Internet Protocol. For those of you who are not computer science majors, I don't expect you to know everything involved in this. I may ask you to tell me at some point what TCP/IP stands for. This is a protocol, guys. When I say it's a protocol, here's the way it works. And we'll get into the way this stuff all breaks up. Transmit Control Protocol essentially means that it tries to verify that a communication has been sent. In the old days, for example, let's say Adam, because Adam's very far from me here. Have you ever talked over a radio? So whenever you finish your sentence on a radio, what do you say? This is Tonkin calling Adam, over. So over means I've ended the communication. And if I wanted to know that you would receive my communication, how would I possibly know? 10-4. Speak back and forth. Transmit control protocol on a network does the same thing. It makes sure we get some kind of verification. And we're also going to show you how this breaks up packets and reassembles things. Packet switching, which I'm going to illustrate for you, is one of the most important parts to make the internet work. Particularly before the days of broadband. It works really well with broadband, but packet switching basically meant we could take content and cut it into pieces and reassemble it. And when we get into TCP/IP, we'll talk more about that protocol and also the idea of what we refer to as client-server computing, which is the fundamental backbone of networks. Guys, here's the way to think about it. We start talking about packet switching, we're basically taking something we're digitally communicating and we're cutting it into little pieces so that we can send it out. Has anybody here, I know a couple people who will raise their hands for this, how many of you have either done a ping test or a trace route? Yeah, absolutely correct. So like if we do a ping, for example, and we do it at different times of the day, will it always go through the same switches to get to the same place? What determines that? How many people are on? Because of our wonderful self-healing network, and what else? Congestion as well. And here's the other part of it. If I want to send something out over the internet, if I have this massively large file, this thing that's the size of a bowling ball, if I cut it into smaller pieces, the size of baseballs, I can send them out in small pieces and they get reassembled. That's the beauty of this stuff. So basically, packets go out and they go possibly through different routes, even during different sessions. They arrive at wherever they're supposed to go, and they get reassembled. What reassembles these things at either end is something called a router. By the way, guys, we have somebody coming to campus on Friday who's a former marketing executive from Cisco. Who here has ever heard of the company Cisco? Why are they so important? Yeah, they make most of the routers that power the internet. We're actually going to have somebody, some of us know people who are related to this person. She's coming here to talk to us about Cisco and the routers behind the internet and how those things are marketed. Guys, here's why this is such a big deal. Before we had internet protocol, when we were using what we refer to as circuit switch networks, these are three computers that are trying to communicate. Now watch what happens here. Because we got circuits, so the kind of the characteristic of a circuit can go from one point to the next. So this computer can talk to this computer. When that conversation's over, this computer can talk to this computer, but they can't talk at the same time. There's limited numbers of circuits. We get into packet switching. Look at this beautiful three-way communication that's happening because we can break all this communication into packets and send it to multiple places at the same time. It's why we can all watch Netflix at the same time. What's something you guys are watching on Netflix, by the way? What are you enjoying? Anybody watching You? Yeah, if we all wanted to watch You at the same time, packet switching is why we can do that, because it can break it out and send it to all of us at the same time. If we were relying on circuits, we would have so many circuits, and once we plug those up, we can't possibly get in any further. So to break it down into kind of a binary discussion, we take the original text message, I want to communicate with you. We digitize that, we break it into binary, because everything is a combination of ones and zeros. Once that gets broken down, we break it into packets. The packets get sent out what we refer to as header information. Guys, don't worry if you completely understand this. It's just showing that we're breaking it down. Essentially, we take a big piece of information, turn it into digital, which is ones and zeros. We go from analog to digital. Then we break that into smaller pieces, and we put little headers in the front of that to say, please recombine these in the correct order when they get to the other side. With me so far, guys? This sounds like, something maybe it's not that exciting. It's not that exciting until you have to live in a world without it. When you remember things like having to do dial-up internet, for example. So with me so far, guys? Okay. Guys, we start talking about protocols. And this gets a little abstract. We're going to get through this today, I promise you. Transmit control protocol simply means we have a way of communicating and putting information together in a way that we can send it, receive it, and reassemble it, guarantee that we've got it back in the right order. Let me give you an example. We have good days and bad days with the internet here at St. Francis, do we not? Okay, on a good day, those websites just pop right up, don't they? On a bad day, sometimes we have to wait for them for a while. Usually they'll eventually come up. And that's because between the routers on both ends of the connection, wherever you happen to be going, are trying to make sure that information arrives as it's supposed to arrive. That's what TCP is all about. And this stuff all rides on something we call Internet Protocol. And the Internet Protocol is simply your addressing scheme. So we've got our methodology and we've got our addressing scheme. TCP as a combined package has 4 different layers to it. We put this in an illustration, it will make sense. We've got the network layer, we've got the internet, transport, and application layer. By the way, any of our comp sci guys in here, feel free to chime in if there's a different observation that you have. The network interface layer, once our information is coming at its most fundamental level, it's a physical interface. So for example, whether you've got a wireless network card in your laptop, whether you've got a physical cable coming into the back of this desktop, all that information is our network interface layer. The internet layer, the IP layer, is where we get our addressing from. We have our addressing, IP addresses. Everybody has seen those on a computer. The transport layer, transmit control protocol layer, basically means host to host, and that means we're making sure our stuff is going to where it's supposed to be. And then finally, we have our application layer. Whatever you're doing, whether you're doing HTTP, Telnet, FTP, whatever your application you're actually communicating with is on the application layer. All these things go together. It's like concentric circles. With me so far, guys. I promise you, even if you're not as excited about this stuff as I am, it gets pretty exciting. So let's put this down and let's break it down. We're going to do a very brief graphical recap. So TCP is actually the protocol for connecting all this stuff. IP is addressing. When you have an IP address, that's your unique identifier on the internet. By the way, I'm just going to ask this to see if anybody knows this. What's the difference between a static and a dynamic IP address? Anybody know the difference? Exactly right. It's a good answer. Guys, when we're communicating out to the outside world, for example, our main connection to the internet, our main routers, all these things have what we refer to as static IP addresses. Those are actually unique identifiers we own for those pieces of equipment. For example, if you didn't know Amazon.com or how to spell it, you could enter in a specific web address, a specific IP address, and get directly to their site. Here at St. Francis, it would be very expensive and onerous to give everybody their own hard static IP address. So when you log on to a network, it randomly assigns you an IP address, is what we refer to as an internal address. It's like having multiple internal phone numbers and one external phone number. In the same way where if I called you from my office phone, you would get a number that you could not call me directly back at. That's the same way we manage IP addresses in large organizations. Watch it mapped out in the video, and hopefully this will all add up.